Hello, statistics student. In this video, we continuing on chapter 1.2, part 4. In part 3, we go over some of the sampling method that we can use to do get a random sample. So, namely, we can do simple random sampling where we use a random number generator to select sample. We can select sample from groups by stratified sampling, where we select some from every group randomly. We can do cluster sampling by select groups only, and then pick everyone in that group. Systematic sampling is skipping around. Multi-stage is multiple method combined together. Inconvenient sample, which is non-random. We also mentioned two terms called sampling without replacement. That means you will never select a sample twice. And sampling with replacement, where you might sample someone twice. And if you are actually trying to find different subjects in a sample, you would want to do sampling without replacement. So these are the examples that we want to go over to classify them as to the method. So the first is select 4 students by selecting first 4 who arrive first. This is not random because you are just selecting those who arrive first. So I would say this is the method this described is a convenient sampling, right? The method, the sample is not random. Select 100 customer by selecting every 50th in the customer database. So you obviously have a list of the data, customers, and then the keyword is every 50th. That means you skip around, so it is systematic. You don't divide them into group. You just skip every 50th. C. Select 10 students randomly from each grade in a high school. So 9th grade, 10th grade. So every grade has some. So that is stratified sampling. D. Select a sample of restaurant by randomly select 10 street and select all restaurant in the 10th street. So you are randomly select 10 streets, but select all restaurant in 10th street, so that is cluster. So that it is easier for the researcher to go to the cluster sampling. E. Select 100 voters respond by posting a survey online. So you let the voter or let people come to you. So that's convenience also. And this is a special case of, in addition to being a convenient sampling, it is voluntary because your researcher never select a sample. The researcher let the sample come to you. Okay, people with strong opinion will come. So this is also not random. The next things we want to talk about is something called random sampling error. Okay, sampling error, non-sampling error, and sampling bias. Now, because if we are selecting a random sample, due to randomness of sampling, sample variation will occur. Sample variation, meaning if I pick 10 students in this class and I want to see what percentage are male and what percentage are females. So out of the 10 students, sometimes I have 5 males, sometimes I have 5 females. But if I select another sample of 10 students, you will notice that it's not always 5 and 5. Sometimes I would have 6 female, 4 male. So is it because my sample is not good? No, it is really because of the randomness of sampling. Sometimes I would have 10 that have more female. Sometimes I have 10 that are less female. So we call these sample variation, and they are natural. They are normal. The difference are known as sampling error. Sampling error. The difference to what is actually the percentage, the actual percentage of the population is called sampling error. And the differences are sampling variation. When sample size, well, when I say the difference with the populations, in between two samples, they are just called sample differences or sample variation. But if it's different from the population, it's called sampling error. When sampling size increase, sampling error will decrease. So if I instead of select 10 students, I select 20 students, the percentage of male female will stabilize a little bit for every 20. Okay, sampling error can be analyzed. That means how big the difference is with the populations. This is with the populations. It can be analyzed. If I get the sample from a random sample. What is non-sampling error? Non-sampling errors occurs because of bias. So non-sampling error would occur when the process of sampling is not random. If you only get your sample from your friends, so if the student is a female, she collect 20 friends, so or of course the number of female may be higher in the group of 20 students that she collect. So this error is because of the process of sampling being not random. So this non-sampling error cannot be analyzed. Okay, they have no particular pattern, whereas sampling error due to random sampling can be analyzed because they obey a certain patterns. And the third term is called sampling bias. Sampling bias occur when some subjects are more likely to be selected as others. So although everyone has the same chance, but certain one has a higher chance. So if you do that, then there could be incorrect conclusions. Okay, so we call them sampling bias. Sometimes non-sampling error could be caused by sampling bias also. And so the last things we want to do is, so of course when we want to collect a sample, of course we want it to be representative so that it can represent this population, and because of that we can draw conclusion from the sample to represent the population. Other than sampling, there are other guidelines that contribute to a good statistical study. First is you do not want to have a biased sample. You want your sample has to be representative. So we talk about this a lot. The second is you avoid voluntary response sample. Voluntary response samples also had a lot of sample bias because people that have strong opinion will tend to be in the sample. You do not pick them. Okay, so an internet survey and call-in survey are examples of voluntary response sample. Try to avoid this. Sometimes issues occur such as sample size issues. So if you use a random process, you pick a random sample, but if you don't pick large enough, small samples are more unreliable because the sampling error is very big, especially when you have um, um, when you are but small samples are unreliable, but sometimes they're unavoidable because of cost and also difficult to get people to be in the sample, such as car tests or medical tests. Not everyone wants to volunteer or want to participate in a medical test. Sometimes a statistical study could be influenced by questions. So undue influence would be question to the survey awarded to influence response. So you might not have a good statistical study even if your sample is good. Other issues in a statistical study would be non-response. So you might pick your sample randomly, and you want everyone to give you data. But sometimes people refuse to give you data. So in a very high non-response rate, it would seem that the sample is a voluntary sample. Only people with strong opinion will respond. Usually, if the non-response rate is lower than 5%, we don't call it a problem. Sometimes, if the non-response rate is so high, we might actually pick a sample panel so that those people are always available to be to give you a sample or to give you response. The next things is that might influence a statistical study is self-funded or self-interest study. So this is other than sample problem, this seems to be a big problems in statistical study. Whenever we look at a statistical study, the two things that I always look at is whether it is self-interest study and also how they collect sample. So self-interest study or self-funded studies are study performed by a person or organization where they want the result to support their claim, or they will benefit from it financially. So researcher would have incentive to produce data or produce results that help them. So look at study by looking at who is behind the study. So very often you will see that food company will support a study that promote certain kind of diet, like maybe they would say, oh, sugars is not an issue for diet, or a dairy company would support study on how milk is good for your health. So look at those study carefully because they are self-funded. It is not to say that they're always wrong, but they have a potential to be biased. Then the next two are about how you look at the results. And even if your study is good, your sample is good, sometimes you might make wrong conclusion. So a causality conclusion would mix up correlation with causations. So two things are correlated, meaning that they happens together, but they might not be the cause of the results. So very often when we look at data, we want to see if one affect the other. And when we see this happening, we say that, oh, that must have been the cause, but that is incorrect. So the causal relationship may be just due to a confining variable. We'll talk more details about this in class. This is actually a big issue. A lot of people that are not well versed with statistical study or statistical concept would think that a particular result is the cause. The last one is misleading use of data. Sometimes you have a study that you want to publish, but you will exaggerate the difference by making graphs that show big differences between one versus the other. So these are all the problems that you should be aware of when you are evaluating a statistical study. When you're reading a statistical study result, see if any of these apply. I say the main problems is usually with samples. You should always look at how they select samples. You should always look at who is behind it. So these two are the main thing. And then, of course, a casualty. So do they just use the results to extrapolate that it is something caused another one, or they exaggerate the results? So make sure that you understand how to evaluate statistical study by looking at this all these area. So that is all of chapter 1.2.